Hello everyone, this is John with Ziptopia.org. Today we are going to talk about RFC 3261, Session Initiation Protocol. This RFC replaced 2543. This is now the latest RFC that defines SIP. Now, if you haven't read this RFC, in my humble opinion, you cannot call yourself a SIP expert. Having said that, reading an RFC is like watching paint dry. These are really dry documents. They do not have a single sentence that is not vital to the integrity of the document. So, if you have read this RFC, you not only know SIP very well, but you are also a very patient person. So, for the rest of us who are not so patient, we wanted to create this tutorial RFC 3261 Simplified. We are going to go over this RFC in multiple parts. We are going to use examples. We are going to try to make it simpler to understand for everyone. So hopefully this will help everyone to understand this RFC without reading it and enjoy while doing it. So we are going to start with an introduction to SIP. We are going to capture a sample call. Then we are going to analyze this call, look at different messages that are exchanged, and we are going to finish our first part in this tutorial. So, Session Initiation Protocol, as the name implies, is all about sessions. It's an application layer protocol, as you can see in this figure, that is used to initialize multimedia sessions, modify already existing sessions, and terminate them. It is important to keep in mind that SIP is an application layer protocol. It works independently of the lower layer protocols during communication between endpoints. In other words, SIP doesn't care if you use UDP, TCP, or TLS in the transport layer. TCP doesn't care if you use IP version 4 or RP version 6 at the network layer. It does what needs to be done at the application layer to create, modify, and terminate sessions. Well, this also means you can use UDP, TCP, TLS, IP version 4, IP version 6, RTP, RTCP, and so on with SIP. SIP just doesn't care. It creates, modifies, terminates sessions. So the key word is the sessions here. SIP doesn't provide the services. It just creates, modifies, terminates sessions between endpoints, servers, and clients. So more than often, session description protocol is confused as a part of SIP. SDP is just like any other protocol that is used in conjunction with SIP. Endpoint capabilities, video, audio support, codecs that can be used are all defined as a part of the SIP message body by using SDP. Now, let's go ahead and capture a sample call and analyze it in our next section. Alright, so we have an asterisk now instance and two Kali instances running here. Both Kali instances are using SFL phone to register to 192.168.1.3, the asterisk now in between. As you can see, .20 is one of the IPs, .17 is the other. Kali instance, this one is using 4.4 alias, and this one is using 5.5 alias for the account. Now we are running Wireshark. It's filtered for SIP. We are running Wireshark on the other machine as well, again filtered for SIP. Now we are going to call 4444 from this phone. We are going to answer it on the other. And once we answer the call, as you can see, it's showing that we are using G711. So let's hang up the call. And we have successfully captured a call in our Wireshark capture in both instances. Alright, we captured our sample call, and now let's move on to analyzing it. So let's make this fun so that we understand this discussion better and we remember things from this tutorial better. Let's make it fun. Let's make it as fun as possible, going over an RFC. So let's say Tarzan wants to call Jane by using a SIP phone. When he starts his SIP phone, the phone needs to somehow let itself known so that others can reach it. For this purpose, it sends a register message to a registrar, which in return uses a location service to bind Tarzan's phone to an address of record that others can use to send calls to. SIP is a text-based protocol with request-response exchanges between clients and servers similar to HTTP. So in this scenario, the register message would be a request, whereas the answers from the registrar would be considered response. So this screenshot is taken from the traffic capture we had earlier, in which Tarzan's SIP phone with an extension 55555 at IP address 192.168.1.20 sends a register message to a registrar at IP address 192.168.1.3. Now, this screenshot is the response from the registrar. Keep in mind, in this case, we are using an asterisk now PBX, and it's indicating that the phone needs to provide a password to authenticate. We received 401 unauthorized. As you can see from the highlighted line, we are given some arguments to use to calculate our response. So now our phone adds another row to the register message, this authorization SIP header field, to provide a password. That's the result of the processed authentication algorithm, and it's sent again out to the registrar. So this time the registrar compares the authentication response with its own calculation with the password and algorithm and confirms the phone's registration by sending back a 200 OK response with a row showing the entry that is added to the location service for this client. Please note the highlighted line. Again, the registrar sends back a 200 OK response with a row showing the entry that is added to the location service for this client. Well, now that Tarzan's phone is registered, and we assume Jane's phone is registered as well, Tarzan is almost ready to call Jane. Tarzan knows Jane and her extension, but not Jane's location or her IP address. Well, if they were in the jungle, Tarzan could yell at different directions in hopes to reach Jane. If Tarzan knew which direction to yell at, that would be a much more efficient communication. This is very similar to a laptop in a TCP/IP network trying to reach another network. Instead of broadcasting its message to everyone, a laptop is told to use a default gateway to talk to in order to reach other networks. With the same principle applied, Tarzan's SIP phone needs to be either manually or automatically configured to know where to send its calls to. The next hop in this scenario could be a redirect server, a proxy server, or a back-to-back user agent, among other things. A proxy server simply tries to pass the call over to another hop closer to the destination. Redirect server responds back to the client, in this case Tarzan's SIP phone, with the next hop information for the client to send the call to, instead of doing it for the client, unlike a proxy server. Again, the proxy server does the work, proxies the call to another hop closer to the destination, whereas the redirect server provides back the information for the next hop so that Tarzan's SIP phone can send the call to that next hop. And a back-to-back user agent sits in the middle between the client and the next hop or the other end. Going back to the jungle, let's say Tarzan was told that there was a camp to the north of his location and he should yell towards that direction to reach Jane. If the people in the camp hear Tarzan, they know which tent Jane is in, and they yell towards Jane's tent, they could be considered a proxy server. Again, Tarzan yelled towards that camp. The folks heard Tarzan. They know where Jane is, and they yell at Jane towards her tent. This would be similar to a proxy server. If they instead yell back to Tarzan and point him to Jane's tent's direction and let him to try to reach Jane, they could be considered a redirect server. Again, here, instead of yelling at Jane, they are yelling back to Tarzan and telling him, hey, yell at this direction, this tent, to reach Jane. This is similar to a redirect server's behavior. If, however, someone in the camp wants to help facilitate this communication in a different way and responds to Tarzan with Jane's voice, pretending to be Jane, and do the opposite to Jane, reach out to Jane with Tarzan's voice, pretending to be Tarzan, the communication would still succeed, and the person in the middle would be considered a back-to-back user agent. In the security world, what's described here would be similar to a man-in-the-middle attack if the person in the middle had malicious intentions. Tarzan is now completely ready to call Jane. His SIP phone with the extension 55555 at IP address 192.168.1.20 is registered to an asterisk now PBX with the IP address 192.168.1.3, which is a back-to-back user agent in this scenario. Jane's phone with the extension 4444 at IP address 192.168.1.17 is also registered to the same asterisk now PBX. The pictures here have two windows. The one on the left is the traffic capture from Tarzan's SIP phone, and the windows on the right are the traffic captures from Jane's SIP phone. Tarzan's SIP call starts, as you can see, with an invite request sent from Tarzan's SIP phone to the back-to-back user agent configured on his phone. The back-to-back agent now sends the invite request to Jane's SIP phone. Right after sending the invite request to Jane's SIP phone, back-to-back user agent sends a 100 trying response back to Tarzan's SIP phone, indicating that it's trying to reach Jane. Once Jane's SIP phone starts ringing, the back-to-back agent receives a 180 ringing response from Jane's SIP phone. The back-to-back user agent now sends that 180 ringing response to Tarzan's SIP phone, indicating that Jane's SIP phone is ringing. And finally, Jane answers the call and her SIP phone sends the back-to-back user agent a 200 OK. The back-to-back agent now sends a 200 OK message response to Tarzan's SIP phone, indicating that Jane answered the call. This is similar to the three-way handshake in TCP communication. The call originator, after receiving a 200 OK, sends out an ACK message to the back-to-back user agent. The back-to-back user agent, in return, sends an ACK to Jane's SIP phone, and at this point, just like in TCP communication, the call is established and Tarzan should be able to talk to Jane. After they are done talking, since Tarzan is not yet a gentleman, he hangs up first. Let's say he hangs up first. That is why the bye message is seen from Tarzan's SIP phone to back-to-back user agent on the left, and then from back-to-back user agent to Jane's SIP phone on the right, per the source and destination IP addresses in these screenshots. At this point, Jane's SIP phone simply confirms the receipt of the message with a 200 OK back to the back-to-back user agent, and back-to-back user agent sends a 200 OK back to Tarzan's SIP phone, confirming the call termination. Now, it is worth noting that the ACK messages are only seen as a response to 200 OK messages for invite requests. I want to repeat this. The ACK messages are only seen as a response to 200 OK messages for invite requests. In other words, you won't see ACK messages as a response to 200 OK messages if it's not an invite request that resulted in the 200 OK message. That is why, during the course of this sample call, even at the end with the bye 200 OK exchange, there is no other ACK message. So this is the end of our RFC 3261 simplified tutorial, part 1. If you have any questions, comments, or requests for other tutorials, please let us know. Thank you so much. Bye-bye.